Section 10.2.23. Several years ago, 43% of parents who had children in grades K through 12 were satisfied with the quality of education the students receive. A recent poll asked 1,235 parents who have children in grades K through 12 if they were satisfied with the quality of education the students receive. Of the 1,235 surveyed, 536 indicated that they were satisfied. Construct a 95% confidence interval to assess whether this represents evidence that parents' attitudes towards the quality of education have changed. First thing we want to do is we want to verify if the value of n, which is the sample size, is less than or equal to 5% of the entire population. Okay. So that means that n has to be less than or equal to 5% of the population. Well, the sample size is 1,235, and it is certainly less than 5% of all the population of parents. Next thing we want to do is we want to be able to verify that if we take these values of the sample times the population proportion times 1 minus the population proportion, is it greater than or equal to 10? So what do we know? We know that the value of n, which is the sample size, is 1,235. And we also know that the value of the population proportion is equal to 43%, which as a decimal is 0.43. So let's go ahead and plug that in. So we know that n is 1235. We're going to multiply that by 0.43. And then multiply that by 1 minus 0.43. And we want to check to see if it is greater than or equal to 10. When we multiply that all out, we get 303, which as we can see is greater than 10. So therefore, it's going to verify all the results. Okay, step number 2. Okay, what we want to be able to do now is we want to be able to then determine, okay, what is the null and what is the alternative hypothesis? Well, again, the null is going to have the equality, and the alternative is going to have either the inequality or the not equals. Okay, so in the question, it tells us that the proportion is 43%. So we know that the null hypothesis, which is a proportion, is going to equal 0.43. Okay, and so what we want to do is we want to find out, okay, whether this represents the evidence that parents' attitudes towards the quality of education have changed. So it doesn't say greater than, doesn't say equal to. So that means this is going to be not equals. So that means that P is going to not equal 0.43. Okay. Now the next thing that we want to do is we want to be able to find since we're going to construct a confidence interval, we need to find the lower bound and the upper bound. Okay, so here are the formulas for the lower bound and the upper bound. So this one, the first one represents our lower bound, and then the last one is going to represent our upper bound. Okay, now before we do that, let's find out our information that we need. Well, we know that the sample size, n, is equal to 1,235. Okay, and then we also know that the value of x, meaning how many parents indicated that they were satisfied, were 536. So we need to find the point estimate. Well, the point estimate is taking x and then dividing it by n, which is equal to 536 over 1235. So let's go ahead and find that on our calculator. So if we take 536 and divide that by 1235, then we get 0.43400. So we can write this as 0.434. Okay, and then we also need to find the critical value. Okay, so let's talk about the critical value here. We know that we're constructing a 95% critical value. So that tells us that alpha is going to equal 1 minus 95%, which we know is going to be 5%, which is 0.05. And so alpha divided by 2, which is 0.05 divided by 2, is going to give us 0.025. Okay, now if we want to be able to use the table, then what we would want to do is we're going to take 1 and then subtract 0.025. And that's equal to 0.975. So that's 0.9750. Okay, so let's go ahead and determine that on our table. So we're looking for the area of 0.9750. So we can see that it's located here, which tells us that we have 1.96. And if you look over here, when we have a 95% confidence interval, the critical value is 1.96 from our ones that are commonly used. So therefore, we know that this is going to be 1.96. Okay, now again, another way of doing that is if you want to use your calculator, then you would use INV norm. Okay, with the area of 0.975, the mean of 0, and a standard deviation of 1. So let's go ahead and do that on our calculator just to verify that. Second distribution, we're going to go to INV norm. We're going to put in the area of 0.975, or 1 minus 0.025. There's 0, there's 1, and then we're going to paste. And then here you can see we get 1.96. We run it to 2 decimal places. And then if we wanted to use StatCrunch, then we would go to StatCrunch. We would select Stat, go to Calculators, and we're going to go to the normal distribution. And so we know our mean is 0, our standard deviation is 1. And so we want that value, which is the area of 0.025 here on the right. So we want it to be greater than, and that area is going to be 0.025. And then when we compute, then again, you're going to see what that critical value is going to be, okay, which is 1.96. So again, that's just a review of what we've done in the past to be able to find that critical value. So therefore, there it is. Okay, so now what we're going to do is we're going to plug this information in to find the lower bound and the upper bound. Okay, so what do we know? We know that we have 0.434, and then we're going to subtract the critical value of 1.96 and then multiply it by 0.434 times 1 minus 0.434, and then we're going to divide that by n, which is, go ahead and put that in there, 1235. Okay, and then over here, it's going to be the same thing. The only thing that's different is that now we're going to be adding. So therefore, it's going to be plus. Okay, so let's go ahead and figure that out. So again, this is our lower bound. And this is our upper bound. Okay, so in our calculator, okay, we can use order of operations to be able to determine what our result is. So we can start underneath the radical. We're going to take 0.434, and then we're going to multiply that by 1, put parentheses here, parentheses 1 minus 0.434. And then we're going to divide that by 1235. And then we're going to take this answer. So we're going to take second square root, and then we're going to go second answer, and then take the square root of that. Then we're going to take this number and multiply it by minus 1.96, which is negative 1.96. So times negative 1.96. And then we're going to add 0.434. Okay, so if we round it to 2 decimal places, we get 0.41. So we get 0.41 for the lower bound. And then for the upper bound, we're going to do the same thing. So again, we're going to take 0.434, multiply that by 1 minus 0.434, and then divide that by 1235, and then we're going to take the square root of that answer, and then now we're going to multiply it by positive 1.96, and then we're going to add 0.434. And here, rounding that to 2 decimal places gives us 0.46. So now we need to ask ourselves, does 0.43, does it fall within this interval? Well, as we can see here, that 0.43, which is what's in the null hypothesis, does fall within this interval. It is between 0.41 and 0.46. So now we can state our conclusion. Okay, so if the proportion stated in the null hypothesis is not contained in the confidence interval, then you conclude that the proportion has changed. Otherwise, if it is, then you conclude that the proportion has not changed. Since the interval contains a proportion stated in the null hypothesis, there is insufficient evidence that parents' attitudes towards the quality of education have changed.